Hi, today we are starting our revision program. So, in this revision program, we are using past paper questions from each lesson and we'll discuss how the examiner is questioning from us, right? How he is testing our knowledge. So, you can understand the very similar questions have been asked for the past few years, and so we predict this will be continued in future as well. So we'll see how it's going. So the second chapter number 2, financial mathematics for business. So we are taking the questions from past papers in 2020 January, 2019 July and 2019 January. So we are taking these three past papers and discuss the questions we come across under this each and every subject topic, right? So the chapter number 2, now we are discussing chapter number 2, financial mathematics for businesses. Right, financial mathematics for businesses. Right. So we'll take the question from 2020 January exam paper. So take the 2020 January exam paper. So we are not providing any tunes here. So you have to take the past paper, 2020 January past paper. So take the 2020 January past paper. We are going to discuss about the question number 2, consists of 10 marks. So we'll see what it says. So there are two parts, part A and part B. We'll take the part A. It says Mahesh invested rupees 750,000 in a special savings account. So he invested, Mr. Mahesh investing 750,000 in a special savings account, right, of a bank at an annual interest rate of 12%. So the annual interest rate is 12%. And compounded quarterly. So especially say it is compounding quarterly. So it is asking you are required to calculate the following in his account at the end of second year. Okay, question number 2, part A, point 1, the total amount in his account at the end of the second year, right? The total amount in his account at the end of the second year. So what is the equation? Remember the equation, future value equation, right? We are saying the future value is equal present value multiplied by 1 plus r to the power n, right? 1 plus r to the power n. But this interest rate is compounded quarterly. So we divide this r from m, we multiply this n from m. M means number of time it is compounding. If it is month, M is 12. If it is quarterly, M is 4. If it is half an year, M is 2, right? Okay, so we'll substitute the figures that we have. So present value is 750,000 into 1 plus 0.12 divided by 4 into the N is 2 years and multiplied by 4. So take the answer. So take your calculator. You're typing 750,000 into 1.03 actually. To the power 8. So 950,000 77 rupees. The value is 950,000 77.56. So this is the amount that we will receive at the end of the second year. So very easy. The total interest earned. Then the point number 2, it is asking total interest earned. How we are going to calculate the total interest? Yes, it is very easy. We will receive 950,077 rupees and 60 cents at the end of the second year. For what? We have invested 750,000. For the investment of 750,000, we are receiving 950,077 rupees. That means what is the total interest we receive? It is 200,077 rupees and 60 cents. Okay. Okay. Part A is completed. 6 marks we have earned up to now. So come to the part B. It says someone borrowed rupees 500,000 at an interest rate of 14% compounded annually. So the second one is Saman. Saman borrowed. He's borrowing 500,000 at an interest rate of 14%. So interest rate compounded annually. So no need to write that. Annual interest rate is 40% and it will compounded annually. This loan should be repaid in 5 equal installments at the end of the every year. So within 5 years this should be set off or settled. So you are required compute the value of an installment to be paid per annum on this loan. So you have to calculate the value of an installment, right? Value of an installment. Right. Then in here, so someone is taking 500,000 as a loan, and he should pay off this loan or settle this loan in 5 installments, right? First, second, third, fourth, and so after the 5th installment is paid, his loan liability is set off, right? So they are asking what is the amount of an installment when the interest rate is 14% and compounded annually. Right? So at the end of each year, the installment is paying. So at the beginning, they are taking 500,000. This 500,000 is the present value. So remember, if we are facing or if we are identifying same installment in every year, the same amount, same figure in every year, we called it as an annuity. You remember this word, right? What is an annuity? Annuity means it is an installment where you can find in each year or each occasion the same amount. So here the annuity is unknown. We have to find out the annuity. Annual interest rate is 14%, compounded annually. So we calculate the present value is equal an annuity multiplied by annuity factor. Annuity factor. So the present value is now 500,000. So it is equal an annuity we don't know, but we can find out the annuity factor. How? What is the equation for the annuity factor? Annuity factor equals 1 minus 1 divided by 1 plus r to the power n divided by r. This is the annuity factor equation. So here 1 minus 1 divided by 1 plus 1/4, that is the interest rate. Since this is compounded annually, so we are directly putting it as 0.14. If it is compounded quarterly, we have to divide this by 2. If it is 4. If it is half an year, we have to divide this by 2, right? Since this is annual, so annually compounding, we are directly putting the 0.14 here. And to the power n, how many years? 5 years. 5 years. Divided by r, r means 0.14. Right? 0.14. Okay, we'll take the answer. Right? We'll take the answer. One divided by 1.14 to the power 5. So how we are going to take this answer from the calculator? First you have to take the answer for this part. 1 divided by 1.14 to the power 5. Then you have to minus from 1. We are typing 1 minus answer. Then you have to divide it by 0.14. So divided by 0.14, it is 3.433. So this 3.433, we take it here, right? 3.433. So we can directly identify A equal 500,000 divided by 3.433. So what is the value of an installment? 145,641 rupees. Or we'll say approximately 42 rupees. So this is the value of an installment when it is compounded annually and paid at the end of the period. Right? Okay. So 10 marks from this question. So now we will move to the 2019 July paper. So the next one, 2019 July paper. That is also question number 2. Right? Question number 2. Okay. Then 2019 July paper. Question number 2. Part A. So we're discussing now part A, right? Rose invested 500,000 in a bank account at an interest rate of 9% compounded annually. So invested 500,000 in a bank account. Interest rate is 9% compounded annually. Right? You are required to calculate the total amount in her account at the end of the third year. It's very easy, right? Future value is equal present value into 1 plus r to the power n. So in here it is compounded annually, so we don't have to modify this equation. We can directly substitute. How? The present value is 500,000 for investment, and the interest rate is 9%. 9% means 1.09, and the duration, number of years at the end of the third year. So n is 3. So what is the figure? What is the amount? 500,000 into 647,514, right? 647,514.5. So 3 marks. Then the part B, to come to the part B, what it says, right? It says and obtain a loan of 75,000 at an annual interest rate of 8% compounded annually. So and obtain a loan of 75,000 at the rate of 8% annual interest rate, right? Compounding annually as well. So repayable in equal annual installment at the end of each year over the 3 years. So and is repaying over 3 years. So you are required to calculate the value of annual installment, prepare the loan amortization schedule for the above loan. So we'll see. We'll calculate the annual installment value, right? First, number 1, calculating annual installment value, right? Calculating annual installment value. So how we are going to calculate the annual installment value? The same way, the equation present value is equal and annuity multiplied by annuity factor. Annuity multiplied by annuity factor. So annuity factor, how we are going to calculate the annuity factor? Annuity factor is equal 1 minus 1 divided by 1 plus r to the power n divided by r, right, divided by r. So in here, in this example, 1 minus 1 divided by, what is the rate? 8%, right, compounded annually, 1.08, and for 3 years, right, 3 years, 3. $2.577. So in here, the present value today we are taking the loan amounting 75,000 to 2.577. So A equals 75,000 divided by 2.577. So 75,000 divided by 2. It is 29,104. Let's say 4, right? Actually 3.6. Let's say 4. So this is the annual installment. Then the second part, it's asking the amortization schedule, right? Prepare the amortization schedule. So the year loan outstanding at the beginning, interest for the period, and repayment amount, loan outstanding at the end. Loan outstanding at the end. Right? Okay, the very first year, this is about 3 years, right? The very first year, the loan outstanding is 75,000, and interest is 8% per annum, right? 8% per annum. So we are taking 8% from this 75,000. 75,000 into 0.08. It is 6,000, right? And what is our installment? 29,104. So we are paying 29,104 rupees at the end. So what is the end result? 75,000 plus 6,000 minus 29,104. It is 51,896. 51,896. So we are coming to the year 2. The opening balance is now 51,896 and interest is calculated on this amount at the beginning of the period. It is 51,896 into 0.08. 4,151.68. We'll say 4,152. 4,152. Again we are paying 29,104 rupees as our second installment. So we are adding 51,896 plus 4,152 minus 29,104. It is 26,944. So when we are coming to the third year, the opening balance is 26,944. We have to take 8% for this, multiplied by 0.08. 2,155.52. 2,150. We'll say 6. Again we are paying 29,104 rupees as our installment. So 26,944 plus 2,156 minus 29,104. So here actually it is equal 0. There is a small gap between actually here the minus 4. Why we are experience minus 4 is the error of rounding up. So we are rounding up this figure, right? Rounding up this figure. So that error we have to set off from here actually. So the final payment is 29,100. So the loan will settle, right? Loan will settle. So this is the amortization schedule. So we have discussed the equation number 2 of 2019 July. So we'll move to the equation number 2 of 2019 January. So now we are discussing about the 2019 January equation number 2. So come to the 2019 January equation number 2.